Hey everyone, welcome to a short presentation about Tap Changer, which can also be called as graduator sometimes. I'm Arvind Subbulakshmi Manikam, right now pursuing my BA Mechanical Engineering. So let's step into this video. So in this particular short video, we'll learn about tap changers that are used particularly in electric locomotives. Inside electric locomotives, the tap changers are placed inside the transformers. The transformers that are used in electric locomotives are called auto transformer, which is an electrical transformer with only one winding. This auto does not refers to the automatic mechanism, whereas it refers to the coil acting on itself. In these type of auto transformers, portions of same winding can act as both primary as well as secondary side of the transformer. Getting into the tap changer, a tap changer is a device that is fitted into a transformer for regulating the output voltage of required levels. So to know briefly about how a tap changer works, we have a short picture on the right side, and all those pointy antenna things that we have are called as the taps. And the tap changer alters the turn ratio of the transformer on the system by altering the number of turns in one winding of the appropriate transformer. So in order to change the number of windings of the transformer, we have to select each tap, and by changing the taps, the number of winding may increase or decrease accordingly. These tap changer offer variable control to keep the supply voltage within the limit, and each tap has its own limit. One tap has a limit for about 20 volt, and the other tap will start from 20 and go till 40, and each tap has its own. These tap changers are of two types. One is the offload uh, tap changer, sorry, the off-circuit tap changer, and the other one is called the on-load tap changer. The offload tap changer can also be called as off-circuit tap changer or the generalized tap changer. This is a tap changer utilized in situations in which a transformer's turn ratio does not require frequent changing, and it is permissible to degeneralize the transformer system. Whereas the purpose of this on-load transformer is to regulate the output voltage of a transformer. It does this by altering the number of turns in one winding and thereby changing the number of turn ratios of the transformer. Moving on. So we have to know about what a transformation ratio is. This transformation ratio, as it is given, V1 by V2 is equal to N1 by N2. Now we use this transformation radio in order to find the secondary voltage. And we have a couple of tables here, as you can see. And for example, uh, if the number of turns in the primary coil is 2750 and the number of turns in the secondary coil is 100, we have to have the turn ratio and the transformation ratio in equal number. So let's say we have an output input of 11,000 volt, and we need to get an output of 400 volt. So in order to find uh, the transformation ratio, we'll use this number of turns from the primary and secondary and find the turn ratio. And with that, we could use it to find the secondary voltage. So in mathematical equation, you will have as V2 is equal to N2 by N1 into V1, right? So that's how we'll use this tabular column. And for different voltages, we have different values as listed out in this tabular column. Moving on, we'll see about what an on-load tap changer is. Uh, in this type of tap changer, we have three major steps. One is the tap selector, one is the fixed contact, and the other one is the moving contact. This tap selector is used to select the appropriate taps. This fixed contact is used to hold a fixed position, and the moving contacts moves to open or close appropriate taps. And we have a picture in the right side to identify all these three types of different equipments. Now, in order to understand about the switching sequence of the tap changer, we'll take a deep look into this picture. Now, the switching sequence happens accordingly to the AVR feedback that we receive. Now, a tap that is closed has to be changed to the tap that we require, right? So, after the tap is selected, the moving contact move and closes both the taps for a while. Now it moves further and finally completely opens the earlier tab and then closes the tab that we require right now. Now during this process, the moving contact closes two tabs for a while during tab changing processes, due to which a circulating current will start to flow. This current needs to be minimized. So for limiting this current, we use current resistors or reactors. Here we could see a physical construction of a tap changer. On the right side, we could see a picture where there is the diverter switch or the oil compartment which is present above the tap selector. And on the left side, we have something called as an MDU. This MDU is called the motor drive unit. This unit has got a motor driver and other necessary controls. Motor charges the spring to rapidly perform the switching process. Power is transferred via shaft and gear mechanisms. Due to the frequent changing of taps, it has to be monitored and maintained properly. Because of this opening and closing of contacts, the sparks are produced, and due to which the oil degrades over time. This oil has to be tested, and analysis needs to be done in lab at regular intervals. These contacts also wear over the time after a number of operations. The oil seals damage over the time, and leakage will definitely happen. Maintaining the oil level is must. For conditional monitoring, it is a must to check for the oil leak and levels regularly. The cost of tap changer could vary from 3.5 lakh to 10 lakh rupees. Now, this variation depends upon the number of taps that is present, and it also depends upon whether you have a diverter unit or not. With a diverter unit, the cost of the tap changer will definitely increase. Without a diverter unit, you might get it around 3.5 lakh. So we are the end of the presentation, and I hope this video helped people to understand the use of a tap changer and why it is very important in an electric locomotive. And I thank everyone once again for watching this video. Thank you.